Let me just do a couple of problems from 1.1. Now this is page 7, but page 7 is for the 11th edition. For the 10th edition was page 36. Oh well. Okay, so given 2 points, say piece of 1 with coordinates x1, y1, and piece of 2 with coordinates x2, y2, then 1, the distance d from P1 to, let's just say between, there's no direction here, P1 and P2 is distance equals the square root of x2 minus x1 square plus y2 minus y1 square. And 2, the midpoint. That is the point halfway, exactly halfway between P1 and P2. The coordinates, the midpoint M plus coordinates, the average of the x coordinates and the average of the y coordinates. So that's nice. Let's look at number 60. In problems 59 to 62, find the length of each side of the triangle. Find the length of each side of the triangle. With vertices P1, P2, P3. State whether the triangle is isosceles, right, or neither. State if the triangle is isosceles, right, or neither. Okay, so number 60, P1 has coordinates 2, 1. Piece of 2. Oh, that's it. Okay, P1 is negative 1, 4. I was reading number 59. P2 is 6, 2. And piece of 3 is 4, negative 5. Okay, now if you want, you can graph them. So negative 1, 4, 1, 2, 3, 4. That's P1. P2 is 6, 2, 1, 2, 3, 4, 5, 6, 2. The x and the y-axis. And P3 is 4, negative 5. 4, 1, 2, 3, 4, 5. Piece of 3. Okay, so here's the triangle. So, oh, by the way, the triangle could be isosceles and right also. Okay, so to determine if it's isosceles, then you would have two sides of equal length. If it's a right, you have to have a right angle, or two sides perpendicular. Okay, or you could also say if a squared plus b squared equals c squared. If the sum of the squares, two sides equals the square root of the second, then it's also a right triangle. I think we're gonna use that. This. So we're gonna check if a squared plus b squared equals c squared, and we're gonna check if we have two sides of equal length. So for both of them, in order to answer both parts of the question, we have to find the length of the sides.
What's the word right before the colon? It starts with an I. What's that word?
Up above?
No, right before the colon, where it says two sides of equal length. What's that word that starts with an I?
Isosceles.
Right?
Thank you.
Oh,
Thank you.
This one. I saw this. I couldn't see that colon. Okay. Any other question? Okay. All right. So we want to find the length of the sides. And to do that, we're going to use the distance formula, right? So we're going to use the distance formula 3 times. So, so to find the length of the sides from P1 to P2, let's call it the line segment P1 to P2. Okay. So then that means I'm looking at this two sets of coordinates. So it's the square root of the difference on the x component. So 6 minus -1 plus 2 minus 4. And they are square, you add them and then take the square root. So that's the square root of 6 minus -1 is 7. 7 squared is 49. 2 minus 4 is -2. -2 squared is 4. So that is 53, square root of 53, and 53 I believe is prime, so that's it. P2, P3. So P2, P3, now we're looking at these 2 points. Now, you can call P3 to be the P1. So we do x2 minus x1. So you can do 6 minus 4 and 2 minus -5, or the other way around. But if I do 6 minus 4 and 2 minus -5, then I get 6 minus 4 is 2. So I get 2 squared plus 2 minus -5 is 2 plus 5. 7 squared, so it's 4 plus 49. 53. So then right away we have isosceles. We found 2 sides that have this equal length, P1, P2, and P2, P3. So now let's find P1, P3. So I'm looking at those 2. P1, P3. So that's the square root of 4 minus -1, or the other way around, plus -5 minus 4. So 4 minus -1, that's a 5 square. -5 minus 4, that's a -9 square. So it's 25 plus 81. So that's 106. Okay, so we check the isosceles. Now we check if it's a right triangle. So we're looking for applying a squared plus b squared equals c squared. C has to be the longest side. So between the square root of 53 and the square root of 106, square root of 106 is longest. So I call this C and the other ones are A and B. So is A squared plus B squared equals C squared? Question mark. Oops. So then I get apply square root of 53 square plus square root of 53 square. Is that equal to square root of 106 square? So square root of 53 is just 53. So left side is 53 plus 53, which is 3 plus 3 is 6, 5 plus 5 is 10. Is that equal to square root of 106 square? Well, square root of 106 square is just 106. So that checks. So then that means it's also a right triangle. So that is a right isosceles or isosceles right triangle. Any questions?
No.
Okay, very good. So in this section, we're applying these two formulas. Let's do 46. Find the midpoint. Between P1 and P2, P sub 1 and P sub 2, where P sub 1 for 46 is A comma A, and P sub 2 is 0, 0. Okay, so my x1 is A, my y1 is A, my x2 is 0, my y2 is 0. Write the formula for the midpoint. X1 plus x2 over 2, the average of the horizontal components gives you the horizontal component. The average of the vertical components gives you the vertical component. So A plus 0 over 2 and A plus 0 over 2. So then that means that the midpoint is A over 2 comma A over 2. Okay, so sometimes you'll be given the coordinates as being letters. So then your answer will most likely have those letters, that is parameters, as your answer. 53. Suppose that A equals, the coordinates for A are 2, 5, are the coordinates of a point in the X prime. That A, let's just say is a point in the XY plane. A, find the coordinates of the point. If A is shifted 3 units to the left and 4 units down. A shifted 3 units to the left and 4 units down. Okay. Can anybody give me an answer right now?
Yes, it's going to be -1 and +1.
and positive 1. Okay, so would you like to tell us how you got there?
I took the x, which is 2. I deducted 3 units, so it's going to be 2 minus 3, and then the 5 is going to be minus 4.
Okay, so you started with A with coordinates 2, 5. And since we're shifting 3 units to the left, so you're saying now my coordinates are 2 minus 3 comma 5, right?
Yes.
So then negative 1, 5. And then
4 units down, that means 5 minus 4.
and that
it's going to
takes
be
you negative 1. Very good. Okay. So now let's visualize it. Okay, so then we start with 2, 5. One, 2, 3, 4, 5. So this is point A. So we move 3 units to the left. So I go 1, 2, 3 units to the left. Notice that the y component hasn't changed. The y component hasn't changed. And the x component has gone from 2 and you backtracked 3 units. So 2 minus 3. And then that's what you end up with, negative 1. So this was 2 minus 3. That's that point here. And then we move 4 units down. So let's do a different color. So I go 1, 2, 3, 4 units down. The x component hasn't changed, but the y component has gone from 5, 4 units down. So 5 minus 4, 1. Very good. So that is the 1, negative 1, 1. Okay, so when you're moving horizontally and vertically, you can just do the arithmetic on the x and the y components. Any questions? Okay, so that is the end for 1, 1. Now we skip to 1, 4. And we're doing circles. And circles is a nice application of the distance formula. Okay. So we all think of a circle as some kind of a shape like this, right? Now, usually we identify the center, but the center is a reference point, it's not part of the circle. So then we defined, and then so what happens is that every point on the circle has a distance to a center, but if you take another point to the center, the distance have to be the same, right? So that's how we define a circle. The circle is the set of all points so this is two-dimensional in the XY plane that are equidistant. That is, they have the equal distance from a fixed point or the center of the circle. Okay, so that's a reference point. Okay, so so that's a circle. So this is what gives us the way to, and that's called the radius. That's how we find the equation of a circle. This fixed distance to the center is called the radius of the circle. So now we're going to find the equation of a circle. So there are two things that we need to define a circle. One is the center, and the other one is this fixed distance. So the first thing we're going to do is we're going to look at the simplest case, find the equation of a circle with center at the origin. And of course the origin is 0, 0, and radius r. So we're looking at, okay, maybe it's getting too crowded here. Let's do. So we have a circle, x, y axis, and my center is the origin, and then we have radius r. Okay, so if this is a point on, if P is a point on the circle with coordinates x, y, so the question is, what are the conditions for x, y so that the point is in the circle? So the condition is that the distance has to be to the center has to be r. Okay, so P is on this circle. If the distance from P to the center is r. And we're gonna denote that by dpr. So we have 2 points with coordinates x, y, and 0, 0. So then we can apply the distance formula. So this distance is r, or actually I should do the other way around. R is the distance between these 2 points, which is the square root of the difference of the x components, x minus 0 squared plus y minus 0 squared. And then we simplify, so we get r equals the square root of x squared, because x minus 0 is x, plus y squared. And usually you get rid of the square root, so square both sides. So we get x squared, change sides, plus y squared equals r squared. So this is the equation of a circle. Center at the origin with radius r. Okay. So example. Find the equation of the circle. We center at the origin as shown. X and y axis, and say this point is 7, 0. And of course the origin is 0, 0. So if I'm given the point 7, 0, then that means I could find the radius of the circle, right?
Yes.
So then the radius will be, what is the radius of the circle?
The distance between C to the point.
Yes, so let's call this point P. Okay, so find the distance. Apply the distance formula, simplified, what do you get? Seven minus 0 is 7.
40.
So you get square root of
49.
9, and the square root of 49 is
7.
7. Okay, now you could have seen it also because you see this line segment is horizontal. So then they both have the same y component. So then the distance will be just the difference on the x component, 7 minus 0. Okay, so that's another way of looking at it. And that's just because this is a special case. Both points are on the same horizontal, or you could also apply it for vertical line. Okay, so then the radius is 7, the center is 0, 0. So then what is the equation of the circle? So it's going to be x squared plus y squared equals r squared, where r is
7.
7. X squared plus y squared equals 7 squared. Or x squared plus y squared equals 49. Okay, so, and then you can play around if you want. So if you want to verify, so let's do, if you want to check, then what you do is you look at x squared plus y squared equals 49, and then you make a table, right? So if you want, you can solve for y. So y squared subtract x squared, 49 minus x squared, and then y equals plus or minus the square root of 49 minus x squared. And then you can play around. You say, well, if x equals 0, for example, that would be plus or minus square root of 49 minus 0, so it's plus or minus 7. So 0, 7, 0, minus 7. So there's the 0, 7, 0, negative 7. If x equals, let's see, I don't know, 4. So then y is plus or minus 49 minus 4 squared is 16. Plus or minus square root of 6 plus 3 is 9. So it's 33. Yeah, 33. So that's approximately 6 times 6 is 36. So 5 times 5, 25, 5 point something, right? So if it's 3, so now this is not done in scale. So halfway is 3.5. So this is 3. And then this will be radicals 33 and negative radicals 33, which is 5 point something. Okay, and then I guess you can do into, you can do it, I will circle in the scale and then look and then verify, but it should work. Okay, now, what if I say graph example, graph the circle, or graph the solution for x squared plus y squared equals 5. So then, because it has the same format as x squared plus y squared equals r squared, then the solution must be a circle. So this must be a circle, right? A circle centered at the origin with radius r. So a circle centered at the origin with radius r. So now the question is, what is r? Well, 5 must be r squared. So from
25. Oh,
the other way around. 5 equals r squared. So what is r? So you see r, after you square, you get 5. So
Square
what
root of
did you
5.
start with? Square root of 5. Yes, square root of 5. Okay, so square root of 5 is between square root of 5 is between square root of 4 and square root of 9. So it's between 2 and 3. So we're just gonna eyeball it. Yeah, go ahead.
How did you get the square root of 5 again?
Oh, because you have the equation r squared equals 5, right?
Mm-hmm.
So if I wanna isolate the r, what do I do?
Square root it.
That's right.
Okay.
Square root on both sides.
Okay, that makes sense.
And then you get it. Now, usually it's r equals plus or minus square root of 5, but we're looking at the radius. So then you pick the positive.
Okay, cool.
Yes. Okay. So then this is my x and my y axis. 1, 2, 3, 4. So this is between 2 and 3. -1, -2, -3. So square root of 5 is between 2 and 3. So I'm not gonna ask you to be very exact. I'm just gonna draw a circle of radius between 2 and 3. So that one. So then what is gonna nail it down is you call this point square root of 5, 0. So then now that tells me that we have a circle, or you can draw this r equals square root of 5. Okay, now what if the center of the circle is not the origin? Okay, so find the equation of a circle centered at h, k. Those are the standard letters. You can call it anything, but it's standard to call it h, k. And radius r. Okay, so again, we need two things to define a circle: the center and the radius. Okay, so then we have, well, the same approach. So say this is my x and y axis, and my circle is somewhere there with the center h, k. So say this is the center. That means this is my h and that's my k. The center doesn't have to be in the first quadrant, it could be any quadrant. So if we go back and see how we derive the equation of the circle, the simplest case, right? What did we do? We took a point P on the circle, and if this point is on the circle, then the distance from P to the center, oh, P to R, what is that R? Please make that change. Should be C. From P to C must be the radius, right? There's no R anywhere. So the distance from P to C, so that line segment must be equal to the radius. We do the same thing, and then we apply the distance formula. So we look at the circle. We take a point on the circle, any point. So P with coordinates x, y. So then we say if P with coordinates x, y is on this circle, then the distance from P to the center must be the radius. So that must be the radius. So we're looking at this 2 points with coordinates x, y, and hk, and the radius r. Apply the distance formula. So r is the distance. So it's the square root of the difference on the x components, x minus h squared, the difference on the y components, y minus k squared. Okay, so r equals the square root of x minus h squared plus y minus k squared. And like before, we get rid of the square root by squaring both sides. So then it's usually written as x minus h squared plus y minus k squared equals r squared. That's the equation of the circle centered at h comma k and radius r. And notice where the hk are. It's right there, and the radius r. Okay. So this is the equation of the circle centered at hk and radius r. So exercises. 1.4 exercises. Now, in the 11th edition, that's page 39. Let's look at number 15. Because we should write the question. Problems 13 to 24.
Is this gonna be like homework due on Thursday as well?
Yeah. Yeah, so we're doing only 2 sections. So the whole 1.1 and 1.4 is due on Thursday. The other ones, chapter 2 is gonna take, you're gonna have more time because there are more sections. Okay, number 15. 13 to 24, write the standard form of the equation and the general form. Okay. So this is called the standard form. And the general form is when you open up the parentheses. Find the standard and general forms. Of the equation of each circle. Okay. 15, the radius is 2, yes. And this and h comma k is 0. Okay. So then this is the radius. And this is the center. Okay, so then we go directly and we say h. Notice that r equals 2. That means that h equals 0 and k equals 2. and then you just plug in. So the format is x minus h squared plus y minus k squared equals r squared. You plug in. So x minus 0 squared plus y minus 2 squared equals r was 2 squared. So the only thing you're left with is x and y. Simplify. X squared, x minus 0 is just x. So x squared plus y minus 2 squared equals 2 squared, which is 4. So this is the standard form. To get to the general form, we want to open the y minus 2. So we get x squared plus y minus 2 squared. Now one identity that comes very handy, because we're going to do a lot of this, is a minus b squared. Okay, so a minus b squared is a squared minus 2ab plus b squared. And that's because a minus b squared is a minus b times a minus b. And when you multiply into binomials, you have to FOIL it. So the product of the first is a times a, which is a squared. The outer is a times negative b, which is negative ab. The inner is b times negative b times a, which is negative ab, right? So because the two factors are the same, then the outer and the inner are always the same. And the last is negative b times negative b is plus b squared. So the outer and the inner, they are always the same. That's why you have two of those, two ABs. So then we apply that and we get y minus 2 squared is the square root of the first minus the product of 2 times y, but it's double. So 2 times y double is 4y plus the square root of 2, which is 4.
What is that
Okay.
identity for? The a minus b squared one? What is that
This,
identity? Yeah. What is that one to find?
what is it called? This is the, this is called a perfect square. And I guess we can call this the square of a binomial.
And we're using that to find what is the point of it?
We're applying it to y minus 2 squared.
Oh, okay. Oh, okay. So we're just basically switching it.
Yeah.
Okay.
So instead of multiplying all the time, you apply that and it saves you one step.
Okay, cool.
Yeah. Okay, thank you for asking. Then we can have a nice classification of that. Okay. All right, so now for the standard form, you make one side 0. So subtract 4 on both sides. So this is gone. And then you also write the x squared and the y squared first, which is already in that order. Then the x, there is no x. So then you just skip and then you have minus 4y equals 0 because this is also 0. So this is the general form. So the standard form has the form x minus h squared plus y minus k squared equals r squared, where the general form is x squared plus y squared, both is using lowercase a, plus ax plus by plus c equals 0. So you see there are no parentheses in the general form, parentheses in the standard form. So what happened is you go to a standard form and you open the parentheses. Okay, any questions? Oh, let's, does it say graph? Oh yeah, it says graph each circle. Okay, so to graph, I just need the center and the radius. X, Y, the center is 0, 2. Oh, I forgot. So we move the X axis. Just a little. Okay, so let me write down here, the radius was 2 and the center is 0, 2. 0, 2. So that's my center. So from there, I go 2 units up and down and draw my circle. Okay, oh, okay, it's not perfect, but just pretend that this is 0, 0, and this is 0, 4. And this will be 2, 2. Okay. So everything about the circle today. Why don't you try one and then I'll take that time to take roll. Number 23, the radius is square root of 13. The center, h comma k, is 5, negative 1. So you're gonna do the same thing. Fine. Hopefully this is not too small. Is this too small for you?
I think we're good.
No.
Okay. Okay. So do the same thing. Find the equation of the circle. So apply the standard form. Simplify. Then open it up to get to the general form. And then graph. Let's take roll.
Miss, is that 5, 4 or 5, negative 1?
4, negative, 5, negative 1. 5, negative 1. 5, negative 1. So let's see how far you got. What is the equation of the circle in a standard form? Did anybody get, say, x minus 5 square plus y plus 1 square equals 13?
Yes.
Okay, very good.
Yes.
So it's just pretty much plugging in. Any questions on this? Does anybody have a question on how to get to that point? Okay.
Is it 13 or the square root of 13?
Well, it's square root of 13 square, so it's 13.
Oh, okay.
Yeah. So x minus 5 square plus y minus negative 1 square equals square root of 13 square.
Wait, I have a question. How did h and
Yeah.
k become x and y?
What was the question?
How did h and k become x and y?
Oh, the formula is x minus h square plus y minus k square equals r square. So then the h comma k being negative 5 comma 1 means that h equals 5 and k is negative 1. Does that make sense?
Yeah.
Okay. And it also comes from if we were to graph this. So let's see. So you see if we have x, oh, we can, I guess we have to graph this, so we might as well do it now. 1, 2, 3, 4, 5, and negative 1. Okay, let me move the 5 above. So that's the 5. So 5, negative 1. So this is the center of the circle. Radius square root of 13. Let's see, square root of 13 is between, I look for perfect squares. 416 and 3 is 9. So it's between 3 and 4. So 3 and 4. So we have, let me see, I draw a circle. The center is there, and between 3 and 4. 1, 2, 3. So let's make it a little bigger, smaller. Tiny bit smaller.
How do you get those numbers? The between 3
Then
to 4.
the 9 and 16.
Yes.
I'm thinking of 1 square equals 1, 2 square is 4, 3 square is 9, 4 square is 16, 5 square is 25. So I'm looking at these numbers. 13, where is 13? 13 is between 9 and 16. So a square root of 13 is between the square root of 9 and the square root of 16.
Okay.
Okay, very good. So then the center is 5, negative 1, right? And if this point is on the circle with coordinates x comma y, then the distance between P and C is the radius, which is square root of 13. So then the radius is the distance from P to C, and then use the distance formula. The square root of the difference on the x components and the difference on the y components. So that's where the h and the k come into play, because then you get x minus 5 squared plus y minus negative 1 squared. And of course, the radius was square root of 13 equals square root of x minus 5 squared plus y plus 1 squared. And when you square both sides, then you get 13 equals x minus 5 squared plus y plus 2 squared, which is the same thing as that. So all that comes from the distance formula.
Wait,
and the
isn't
definition of a circle. Yes.
isn't it y plus 1 instead of y plus 2?
Yes, y plus 1. Thank you. My brain just keeps adding things for no reason. Okay. Well, at least it keeps you up on your toes.
And
Sorry
that would
about that.
that would be the final answer, right? Because that's just the distance.
So that's a standard form of the equation of the circle.
Mhm.
Okay.
But the 13 equals x minus 5 squared, that is like the distance, right?
13.
The 13 equals x minus 5 squared plus 1 plus
Yeah,
y.
that's the equation of the circle.
Okay, equation. All
Right.
bet.
So what does that mean? Is that any numbers that you put in for x and y that make this equation a true statement will be on the circle.
Okay, that makes sense.
Okay.
Thank you.
Any point that satisfies that equation is a point on the circle. Okay, now let's do the general form. So we have to open up x minus 5 squared and y plus 1 squared. Okay. So we go back here, x minus 5 squared plus y plus 1 squared equals 13. So remember the binomial was a minus b squared equals the square of the first minus twice the product plus the square of the second. When you have A plus B, then everything is plus. A squared plus twice the product plus the square of the second. Okay, so if we apply that to x minus 5, then we get the square of the first, that is the square of x. X squared is a minus the product of x times 5, double. So 2 times x, 5x, 10x, plus, so that's the negative 2ab, plus the square of the second. So
25.
5 squared is
25.
25. Okay, plus now we do y plus 1 squared. So we're using the second. So what is y plus 1 squared?
Y square
Plus,
negative plus
Plus
2y
plus
plus 1,
equals
13.
13. Very good. Okay, so to get to the general form, we keep the x squared first, then the y squared, then the x, then the y terms, and then combine like terms. So I get x squared plus y squared. What follows?
Negative 10x,
Then
2y,
and then
26.
plus 26 equals 13. And then one side has to be 0. So what do I do?
Minus 26.
Minus 13.
Oh, 13.
Yes, because I want the right side to be 0. It's just the way it is. So the answer is x squared plus y squared. I'm just copying. Minus 10x plus 2y plus
13.
13.
13. 26 minus 13 is 13. There's your general form. Okay. Now the next set of exercises. So in math, you're always learning something, and then later on you say, okay, what if you go backwards, right? So he does a question. What if I give you the general form, and then I want the standard form? Okay, so this part, so we have to backtrack, right? So you see the 10x and the 2y, they are key because they don't change. The 13 has changed, right? Because there is a 25, there is 1, and the 13. Now it's a coincidence that there's a 2 and 13, and just happened to be the case because 26 minus 13 is 13, but usually won't be. So in order to backtrack, what you want is you want to keep track of the 10x and the 2y. It's not redoing it. Okay. So you want to keep track of the 10x and the 2y. Because what is that? You see the 10x has the key for the 5, and the 2y has the key for the 1. Because how did you get the 10x? The 10x was the double of x times 5, but the coefficient of x is always 1. So it's really double 5. So when you backtrack, you're going to take half of the coefficient of the x and half of the coefficient of the y to get that number. Okay, and that is called completing the squares. Okay, so let's look at problem 29. So 25 to 38. Problems 25 to 38. A, find the center. H comma K. And the radius of each circle. B, graph the circle, and C, find the intersects. Okay, I said let's do 29. x squared plus y squared minus 2x minus 4y minus 4 equals 0. So we start with the general form. Okay, so what I want to go to the standard form. X minus h squared plus y minus k squared equals r squared. Notice that the x appears only one place, the y appears in only one place, and everything else is a number. Okay, so then we backtrack, so as we said. So then the x minus h is the one that contains the x squared and the negative 2x. And the y minus k will contain the y and the 4y. So I'm going to separate them. So I start with x squared minus 2x. I'm going to leave a space, plus y squared minus 4y, leave a space, minus 4 equals 0. So the process of going from that to the, from x squared minus 2x to x minus h squared is called completing the squares. We're going to complete the squares. So the x squared minus 2x, so it's called completing the squares because what you're going to think as x squared minus 2x as being parts of, remember, it was like x minus x, let's do x minus a squared. So that would be the square of the first minus 2ax plus a squared. Okay, so imagine you have these two parts and you want to find a square. So if you find a square, then the whole trinomial will be factor, will be a perfect square. So you'll be able to factor as x minus the number square. So that's the idea. So then the idea is you take the half of the coefficient of x, half of negative 2 in this case. What is half of negative 2? That would be negative 1, right? And that's how you get the a, because 2a is negative 2, so a must be half. So it's negative 1. And then what you need to add is the square of a. So then you have a squared is therefore negative 1 squared equals 1. So what I need, let's do a different color. What I need is a 1. But I cannot just add it to one side because then the equation is not equivalent to the original. So I add it to the other side. Now the equation is equivalent to the original. So I do the same thing for the y's. Okay, so I want to complete the squares. So then the a for the y's will be half of
-4,
negative 4, which is,
-2,
and then what I add is a squared, which is
4.
4. So I add 4 to the left and 4 to the right. Okay, now I factor. So again, we're gonna look at this together and that together. So then we say, okay, x minus 2x plus 1, because we follow this form, then it should be x minus a squared. Okay, so a was negative 1, remember, so it's x minus 1 squared plus the other one would be y minus 2,
Yeah.
with the a is, so it's y minus 2 squared, and then I have a minus 4 equals 1 plus 4 is 5. I want the negative 4 on the other side, so add a 4 on both sides. So now my equation is x minus 1 squared plus y minus 2 squared equals 9. Okay. I need the center of the circle. What is the center? H comma K, right? So
Mhm.
what's H?
-1.
Minus h is -1.
1.
So what's h?
Is it just +1?
Yes. So see the center h comma k will be 1 comma, what is k?
2.
2. 1 comma 2. What's the radius?
Square root of 9.
Square root of 9. So r squared equals 9. So the radius is square root of 9 or 3. So the center of the circle is 1 comma 2. The radius is 3. And that is the answer for part A. Part B, graph. So now graph a circle centered at 1, 2 with radius 3. So that's the center and radius 3. 1, 2, 3. So there you go. So that's a center 1, 2, and radius 3. Part C, intercepts. So x-intercepts and y-intercepts. So it's the same way that you find the intercept of the of a line. So the x-intercepts are going to be the points at which the circle crosses the x-axis. So, but those are points on the x-axis, so that means the y components have to be 0. So then you said y equals 0. And then you plug in. So we have x minus 1 squared. Let's use the standard form. Plus 0 minus 2 squared equals 9. And then solve for x. Plus -2 squared is 4. Subtract the 4. So we get x minus 1 squared equals 5. Keep solving. Now x minus 1 squared equals 5. So to get rid of the square, do the square root. But now I include plus or minus. X minus 1 equals plus or minus square root of 5. Isolate the x. Add a 1 on both sides. So x equals 1 plus or minus square root of 5. And because order of operations says you have to do a square root first, then I can add 1 plus 5. So it's going to be 1 plus square root of 5, 1 minus square root of 5. So 1 plus square root of 5 is positive, so that would be this one. And the other one would be 1 minus square root of 5.
Is it plus or minus square root of 5? Because
Yes.
you're square rooting both sides. Is that what
That's right.
Okay, yeah.
Yes. It comes from this step.
Where did you even get the x minus 1 squared plus 0 minus 2 squared? Where does that originate from?
Here. So remember, we found the equation of the circle in standard form. So, and I let y be 0. So this is 0, and it's the same thing.
Oh, because the x-intercepts are the 0, basically.
Yes. Okay. So the x-intercepts are points on the x-axis, and points on the x-axis have y equals 0. Okay, let's find the y-intercepts. Now, how do I find the y-intercept? What color do I need? Okay. So you see there are these two y-intercepts. So y-intercepts are points on the y-axis. So then that means they have to start with 0 comma something, right?
Yes.
So then we're letting x be 0 now. So I go back to this equation, and now we plug in 0 for x. So then that becomes 0 minus 1 squared plus y minus 2 squared equals 9. or -1 square of 1 plus y minus 2 square equals 9. Now, when you're solving for y at this point, because the y appears only in one place, you see that's the only place that it appears, then you just isolate the variable. So you don't want to open that up. So isolate y. So subtract the 1 on both sides. So you get y minus 2 squared equals 8. What is the next step? Get rid of the square. So square root plus or minus square root of 8. Simplify square root because there is a perfect square that goes into 8, namely 4. So you get the square root of 4 times square root of 2, or 2 square root of 2. Isolate the y, get rid of the minus 2, so plus 2 on both sides. So y equals 2 plus or minus 2 square root of 2. So in other words, y equals 2 plus 2 square root of 2, or y equals 2 minus 2 square root of 2. And 2 minus 2 square root of 2 is going to be negative, so that's the one below. So this is 2 plus 2 square root of 2, 2 minus 2 square root of 2. And there you go. So the one that might take a little work is getting the completing squares down. But once you just follow the steps, look at the coefficient of the x and the y, take half of the coefficient square, and that's the quantity you add to both sides. Any questions? Oh, I guess I should give you time to finish copy. Okay, so I don't think we have time to do anything else. So office hours starts now. And you can ask me any questions you have, or you can ask me to go over anything.
Yes. Can you go over the general form again? I'm still having a little bit of confusion in that.
Okay.
Finding the general form.
To
Can I
find the
ask-
general.
Can I ask a question before you do that? It's just, it has nothing to do with this. So for the homework, if I'm doing my math lab, do I need to scan in my homework problem?
No.
Okay.
You don't need to scan it, but do make sure that you keep good writing habits. Okay, so
Okay.
don't scribble. You know, like your. So if you were to do this in my math lab, then you should show all this work. Okay. Because sometimes when it's online, you just scribble here and there, and then you type your answer. Try not to do that.
So my math lab, I don't understand what you're saying. So I do all of my work on my notepad, which you can't see.
Yes.
So do I need to scan that and send it to you or no?
No, you do not need to scan it, but if you have, If you have all this in your notepad, then it's good.
Okay,
But if you have scribbles, then try not to do that, because sometimes, because you only need to type the answer, sometimes people just scribble and here and there.
okay,
Just pretend I'm gonna look at it, so just show all work.
okay, okay.
That's a good
Thank you.
practice.
Thank
Okay,
you.
I also had a question about homeworks.
yeah,
So the book that you posted, that was behind compared to the one that we're supposed to use, are you gonna post the new homework for that today?
yes.
All right.
I will put the, so you have the, so you go to the same place, homework chapter 1, but
Mhm.
underneath I will have homework for the 10th edition.
All right.
Okay,
Thank you very much.
you're welcome.
But we don't need to do that. The 10th edition if we use my math lab though, right?
Yeah,
Okay.
so the, I guess the preferred is my math lab.
Okay,
Then the textbook 11th edition, and then the last option is the textbook 10th edition.
okay, sounds good.
Yeah. But any of these three forms are good.
Sounds good.
Okay. Okay, so let's, how do you get into the journal form, right? So let's,
Are you going over the form right now or am I lagging?
I don't think he is.
Oh, okay, yeah, I'm not sure. Miss, are you here? Is there screen black for you guys?
No.
Let me leave and rejoin.
She left.
She left.
Yeah.
Okay, I think I got disconnected.
Yeah.
Okay, and then my other computer, oh, I don't know what's going on. All right, so let's do the recording. Oh, it's recording. Okay, share content. Okay, so so we were saying that we want to go to the general form. So basically we gotta open x minus 5 square, and to open x minus 5 square, one way is by using this format: a minus b square equals a square minus 2ab plus b square, right? So then that would mean that a is x and b is 5. Okay, so if I'm using this format, what is x minus 5 square?
Wait, I'm sorry. You said so A becomes X and B
Yes,
becomes 5. Okay.
yes.
All right.
Okay, so then what is x minus 5 squared? That will be the equivalent of a square minus 2ab plus b squared. Okay, let me give you a minute to write that down.
So this is the general form right here. Like that's the,
No,
Oh.
this is like on the side. So we're isolating this part of the problem, and okay, and then we have to go back and then isolate the other one and then go back, add the whole thing, and then make one side 0.
and then that's how you get the general.
Yes, that's how you get the general. Okay,
But right now, this is basically to just give us all the ingredients we basically need to get to that point.
yeah.
Okay.
Okay, so what is x minus 5 squared?
Do we make it 25? X 25, 25x or?
Okay, so okay, let's do it a different way then. Okay, so x minus 5 squared is x minus 5 times x minus 5, isn't that right?
Yes.
Okay, so let's forget about that, and I'll show you how the other one comes into play. So now this is a product of binomials. So in a product of binomials, you can FOIL it.
Can you scroll up a little bit, please?
I wanted
Yeah, right there. Thank you.
okay, I wanted to hide a minus b squared, but that's okay. Okay, in the FOIL method, what does f stand for?
First.
First, the product of the
two.
first.
Right. Which would be 2x.
X times x, okay. So x times x versus x plus x. So x times x, so we are multiplying the same twice, so then the 2 is in the exponent. Because the 2
Right.
here is a counter, right? It's telling you how many times you multiplied. Where x plus x is 1 plus 1x. So that's the 2x, okay? All right, so let's go back and say, what is the product of the first?
X squared.
Very good. What does O stand for?
The origin? I mean, no, I'm sorry. O stands for the outer.
Outer, okay? So that means x times?
X times -5.
Okay, and what does that give me?
X times -5 is
Negative
-5x, right? -5x.
Very good. Negative 5x. What does I stand for?
Inner.
Inner. And the inner is?
-5 and x.
And that gives me?
-5x.
negative 5x also. And the last, L stands for the last, and that is,
-5 times -5.
and that gives me
25.
25. Okay. So when you multiply two binomials, but if the factors are the same, you're gonna see that the outer and the inner are always the same.
Right.
So then, so you're always gonna have 2 of the negative 5x, right?
Right. So it'd be -5x squared.
Double,
Minus
you're adding,
Oh,
25.
so it's twice of the 5x. And how much is that?
10x.
10. Very good. Yes. Maybe at the beginning, just write it out, and then you can see it is 10x plus 25. Okay. Let me add a page here. Okay, so where am I here? I think I add a page here. Okay. So now we can continue here. Oh, I added in the wrong place. Okay, added in the wrong place. So let's move it here. Okay. Okay, there. Okay, so let's put this on the side here. So then I say, therefore, x minus 5 square, x minus 5 quantity square is all that. So that is going to replace that. Okay, so then now we have, instead of x minus 5 square, what do I have?
x squared minus 10x plus 25.
Yes. Okay. Now, now let me compare that with what I was saying before. So we have x minus 5 square equals x square minus, I'm gonna write it as 2 times 5x plus, and then the 25 came from -5 times -5 squared, right?
Yes.
Right.
Because the last, you see the product of the last is the -5 and the -5, and they're both the same. So it's going to be the square always. Now the formula I had above, written above, so is a minus b square is a square minus 2ab plus b square. Do you see that?
Yes.
So the 2ab is the product of the a and the b, which is the 5x. There's the 5x, and the b square is the product of the second. So if you can see that, then the next time you can try to, it will be a little shorter. Instead of doing the 4, it will be a little shorter to just multiply it out. So if I look at the next one, a plus b is, everything is plus, a squared plus 2ab plus b squared. Then if I apply that to y plus 1, let's see if we can do it now. What would y plus 1 be if I follow that format?
It would be y squared plus 2y1
Plus 1.
plus
Yes.
1 squared.
Okay. Is it easier now?
Yeah.
Yes.
Okay.
Wouldn't the 1 be squared or no?
It will be square, but 1
You could just
square
simplify
is,
it to make 1. Okay.
yeah.
Yeah.
So yes, technically speaking would be that 1 is square, but the 1 is special because then it's
Sorry,
just
there.
1.
Yeah.
Okay, so
you
we
just-
bring that up with the y plus 1. Y squared plus 2y plus 1 equals 13.
Okay, hold on.
Yeah, 1 second.
X squared.
Yeah, I think I'm gonna copy this over here because it's getting too crowded. Okay, so we continue from there. So what's the next step?
Simplify it?
Right.
Yes, simplify. And then reorder.
Yeah.
So ultimately, we want to get to the form x squared plus y squared plus little ax plus little by plus c equals 0. Okay,
That's the general form.
yes.
Okay.
This is an x. Okay, so what do I do next?
X squared
Squared. Y
Plus.
squared
Plus y squared
minus 10x
plus
minus 10x, yes, because the 10 is negative,
and plus 2y,
plus 2y plus
26.
26 equals 13. Are we done?
No,
No.
no.
So what do we do?
subtract the 13.
Subtract 13. So now this is gone. Copy this all the way to the 2y, and then you do 26 minus 13, which is
13.
equal.
0.
Okay, so there is your final answer.
Mm.
And that's the general form?
Yes.
Cool.
Okay.
That makes sense.
Very good.
A lot better.
Okay,
Yeah.
very good.
Because when you first went over it, I was like, bro, what? Like, how did you get there?
Oh,
This helps though.
yeah. Yeah, it's important that you ask me because I don't know, you know, I can't go into your brain and see which ones are the
Yeah.
ones you don't understand.
Right.
Yeah.
Makes sense. Okay,
Okay,
cool.
very
Thanks.
good. You're welcome.
I'm gonna go start on the homework now.
Okay,
All right. Have a good day.
thank you. You too.
Bye.
Bye.
Thank you, Miss Hito. Have a
You're
wonderful day.
welcome. So I'm here until 2 o'clock. If you guys run into problems, you can come back.
Yes, ma'am. Thank you.
Okay,
Thank you.
you're welcome.
Have a good one.
Okay, you too. Bye.
Miss Hito, okay, thank you, Miss Hito.
Okay, you're welcome.
All right, bye.
Bye. Are you the last person?
Yeah.
Yeah. Okay. Okay. So I'm here until 2 again if you have run into any problems. Otherwise, I'll see you tomorrow.